I'm going to introduce Taiwan's smart grid development, and this is my summary. We'll cover four main parts: the National Action Plan, communication infrastructure, real-world applications, and finally, my personal reflections. The first part I'm going to do introduction to Taiwan Smart Grid Action Plan. Taiwan initiated its Smart Grid Action Plan in 2011, recognizing the urgent need to modernize its electricity infrastructure in response to increasing energy demands, climate change challenges, and the growing adoption of renewable energy. Approved by the Executive Yuan, the original plan laid out a roadmap to upgrade the national power grid to be more efficient, intelligent, and resilient. Initially, the focus was on establishing fundamental systems such as smart meters, automated substations, and intelligent monitoring platforms. These foundations were necessary for gathering real-time data, enabling responsive energy distribution, and improving the reliability of electricity delivery. However, with evolving energy policies and technological advancement, Taiwan updated the action plan in 2016 and again in 2020. These updates placed greater emphasis on integrating intermittent renewable energy sources like solar and wind, while enhancing grid stability and security. One of the major goals of the Smart Grid initiative is to support Taiwan's broader energy transformation, including achieving 20% renewable energy by 2025. In this context, smart grid technology is not just a technical solution, but a policy tool, enabling better demand-side management, energy efficiency, and consumer engagement. To oversee implementation, the Ministry of Economic Affairs formed a dedicated smart grid task force, which includes representatives from Taipower, academic institutions, standards organizations, and industrial experts. This task force coordinates technical guidelines, funding strategies, and public-private cooperation, ensuring that smart grid deployment aligns with national priorities and global trends. And the second part is method for strengthening communication infrastructure. A key pillar of Taiwan's smart grid development is robust and reliable communication infrastructure. This is essential because the smart grid operates as a vast interconnected system where components like smart meters, sensors, control centers, and user devices exchange data in real time without stable and secure communication. The smart grid cannot function effectively. The first method is the deployment of advanced metering infrastructure, AMI, which enables two-way communication between power providers and consumers. This system collects real-time consumption data, sending pricing signals, and allows for remote control of devices, thereby improving energy efficiency and enabling demand response strategies. Second, Taiwan is investing heavily in the expansion of utility grids, telecommunication networks. These networks include high-speed fiber optics and reliable wireless connection that ensure constant high bandwidth data transfer. Moreover, redundancy mechanisms are built in to prevent communication lost during natural disaster and cyber attacks. Cybersecurity is another critical focus area. As the smart grid integrates more ICT, information and communication technology elements, it becomes increasingly vulnerable to cyber threats. Taiwan has initiated several cybersecurity enhancement projects to protect the integrity and availability of grid data. This includes encryption standards, multi-layer authentication protocols, and security audits of network components. Standardization also plays a vital role. Taiwan adopts international standards such as IEEE, IEC, and NIST guidelines to ensure interoperability between different systems and vendors. This minimizes integration problems and supports the scalability of smart grid solutions across various regions. And the third part is applications of the smart grid in Taiwan. Taiwan has made substantial progress in applying smart grid technologies across its power system. These applications are not just theoretical, they are being piloted and deployed in real-world scenarios. One major area is deployment of wide area monitoring systems, WAMS, using phasor measurement units. This system allows Taipower to monitor the health and performance of the transmission grid in real time. PMUs provide precise measurement of electrical waves, enabling better detection of faults, prediction of grid instability, and faster restoration during outages. Another application is power quality monitoring and management. This involves advanced sensor and analytic tools that detect abnormalities in voltage, frequency, and waveform distortion. When issues are detected, the system can automatically adjust reactive power compensation devices or voltage regulators to maintain optimal power conditions. Electric vehicles (EVs) are also being integrated into Taiwan's smart grid framework. Pilot projects have been conducted to assess the grid impact of large-scale EV charging and discharging. Smart transformers and charging infrastructure are being tested to support vehicle-to-grid (V2G) functions, allowing EVs to serve as distribution energy resources. Energy storage is another important application. Taiwan plans to expand its storage capacity to 1000 MW. In the coming years, battery systems are used to stabilize frequency, support intermittent renewable integration, and enable peak shaving. These systems are often combined with microgrid pilots and smart homes to create localized energy ecosystems. Additionally, smart grid technology has been applied to demand-side management, where consumers receive real-time pricing and consumption data. This empowers them to adjust their usage patterns for cost saving and efficiency. Pilot programs have shown that such engagement can reduce peak loads and improve overall grid reliability. Overall, Taiwan's smart grid applications demonstrate a comprehensive and forward-thinking approach to modernizing the electricity system by combining data, automation, and consumer engagement. Taiwan is building a resilient and flexible energy future. And the last part is my personal reflections. Through this exploration of Taiwan's smart grid alternatives, I have gained a profound appreciation for the complexity and innovation behind modernizing an entire power infrastructure. What, what initially proved to be a pure technical endeavor turned out to be an intricate balance of engineering, policy, and social coordinates. The gradual evolution of the Smart Grid Action Plan, from foundational infrastructure to full integration of renewable energies and EVs, reveals not only Taiwan's ambition but also its adaptability. I found it especially fascinating how communication infrastructure and cybersecurity are positioned as critical enablers rather than supplementary components. The strategic use of real-time data, intelligent monitoring, and consumer participation show a deep understanding that the future of energy is both distributed and participatory. These insights have reshaped my view of what a power grid can be. It is no longer a one-way supply chain, but a dynamic ecosystem that requires cooperation at every level. This study also made me reflect on the broader implications of smart grid for sustainability and national resilience. Taiwan's approach demonstrated how technology can be deployed not just for efficiency, but for long-term social benefit. I believe the lessons learned here can serve as valuable references for other regions aiming to modernize their energy system in an increasing uncertain world. And that's all. Thank you for your listening.